Continuing now with lists, we're going to look at some of the built-in functions that we can use with lists. Things that make it convenient to manipulate a list and things that make it convenient for us to get items into and out of a list. The first function is an index. Index is important because if I want to replace an item in a list, then I need to know the index of the item I need to replace so that I can put the item in the correct place that I want to replace. Right? Index is an important function from that. Generally, when we use functions such as this, such as index, to find an item, we may not find the item in the list. So in that case, we should do exception handling as we learned in the last module. Why? Because you want a graceful exit out of your program. You want your program to say that item was not found. You don't want it to crash, right? So here we have, and again, this is out of your major learning resource, your text. Food, pizza, burgers, chips. Here are the items in the food list. You know you can print a whole list just by giving the name of the list in the print function. What item should I change? So how does this work? Let's go ahead and look at this. And I'm just going to bring my shell next to it. Bear with me for 1 second. All right, here we go. What item should I change? Let's say I say I want to change the ice cream. Now we know ice cream is not in the list. So we have a graceful exit that says the item was not found in the list as opposed to a traceback error with 10 lines written in red. Okay, so let's go ahead and run this again and say what item should I change? I want to change chips. Okay, enter the new value. I want to change it to apples. Now we are promoting a new healthy lifestyle, so no more chips. Enter the new value, and here is the revised list: pizza, burger, apples. Okay, so how did this work? Okay, item index, which is some variable, is food.index item. So once the user enters the item, then the index function is used. It's used on the list food, and the index of that value is returned, and it's stored in item index. New item. Enter the value of the new item, food, and here we are using square brackets as a subscript. Food item index is equal to new item, and that print makes the revised list. Okay, so if we run it once again and enter the item I want to change pizza. To what do I want to change it? I want to change it to oranges. And there is a revised list, oranges. And we all saw earlier what happens if an item is not found in the list, right? So now the next function that is in a list is the insert function. Let me just change the size of that. Bear with me for a second again. Okay, so here's the insert function. This function allows you to insert an item into the list at a specific position in the list, right? Now you can push and pop items in the list as well, but those go not at a specific position. We'll talk about that later, right? Names is a list that has James, Catherine, Bill, 3 names. And names.insert, and we are saying at position 0, insert Joe. Okay, so what do you think the list should be after this? Think about it in your mind for a second, what this list should be. And now, let's run this module. Okay, here is the list after the insert Joe. Where was Joe inserted? Joe was inserted into position 0. Let's insert Joe into position 2 and see what happens. Okay, and here is 0, 1, and 2. Joe was inserted into position 2. If we insert Joe into position 3, okay, what would happen if we inserted Joe into position 7? And what it would do is it would determine that the list was only so long, and Joe would be inserted into the last place in the list, which is really nice because many other programming languages won't do that. If you tried to go so far out of bounds, you would get a runtime error and a crash. So in that sense, it's pretty nice to have this, right? Here is an example of a use of lists where you have Megan's coffee shop, and Megan has 6 employees, and for each employee there is a standard hourly rate for the employee. For each employee, she wants to get the hours worked, store it in a list, and then print the gross pay for each employee. And this is, again, all of these examples that we cover in these videos are straight out of your book so that you have a place to refer back to after you watch the video. Hours is equal to 0 multiplied by num employees. Okay, now we all know, you know from the previous video, you know from your readings, that the multiplication is the repetition operator. It repeats that, it copies that list X number of times, and I'm going to bring that back up. And after it has copied the list so many times, it joins them into one list. Okay, so this is 6. Ours is 6 zeros here. 6 initialized to 0. All right, for index and arranged num employees, enter the hours worked by employee. So that doesn't go, this goes from 1 through 6, right? Enter the hours worked for employee, index plus 1, and we get the hours worked and we store it into index. So here we go. It's gone into index, and we store the hours of the first employee, and so on, and we go through and store the hours of all the employees. And then we have a pay rate. We ask for a pay rate for the employees. And now we go to that same list where we stored the hours, and we traverse the whole list, and we calculate a gross pay for each employee, and we print the gross pay for each employee. So how would this run? This would run like this. Let me close this shell and start a new shell. This would run like this. Enter the hours worked for employee 1, 21, 23, 65, 45, 54, 10, and 22. And hourly pay rate is 10.75 per hour. Oh, sorry, I entered 1.075, but it tells you how the program is going to run. So that's going to be the output of the program. And we'll continue with lists in the next video.